All right, Patriots, I'm sorry that I wasn't able to be in today. I'm over at Wagner doing some observations, and I'll be back with you guys again tomorrow. But let's go ahead and get started on this. This is going to be our first lesson in Unit 12, our last unit of the year. And we're starting off with something pretty simple. You've covered all this before, area of triangles and quadrilaterals. And most of these are going to be just like what you've seen before. And area formulas are nothing new. Well, I guess that might be new for the rhombus and kite when we get down to the second page. But I'm going to be using the skills practice side of this thing as our notes and our examples. And then your assignment, you're going to have the practice sides of these. And I believe that for the assignment, I've already printed that off the correct way. So first off, when we talk about area of a triangle, this is the same formula you used before. Area equals 1/2 times the base times the height. Now, the thing that you've got to keep in mind about this is that when we draw a triangle, there's several ways it can be drawn. The most common one is like this, but you can also have this obtuse triangle here. Now, whenever we talk about the base and the height, the base can be any side of the triangle. It doesn't matter which. So in this case, I would use that as the base. Here I can use this as the base, and here I'm using that as the base. Now the height, in the case of a right triangle, the height ends up being this other side. The only stipulation is that the height must be at a right angle or perpendicular to the base. So on this one, my height is going to end up being here. Now, on my third triangle, the height is going to end up being over here if I had drawn this across. There's my height. So on an obtuse triangle, you end up having a height that is outside of the triangle. Now, for a parallelogram, our area is just going to be base times height. And the same idea applies as before. See if I can get a parallelogram to draw. There we go. You could draw the height on this thing for the base there. You could draw the height here, as long as it's at a right angle, or you could draw the height here at a right angle. Either one works. All right, let's do a couple of examples of this. Turn my calculator on. All right, so on this guy, I'm going to start off by writing the formula, and you'll see on your assignment that it's listed out this exact same way. The area formula is base times height, 1/2 base times height. Then there's going to be areas or spaces for you to write all the different pieces of this, base, height, and then area. So when I go to fill this in, the base is just one of the sides. In this case, the only one I have here is 18. The height is perpendicular to it, and on this obtuse triangle, it's this one here. So we got 12 millimeters. And then for the actual area, I'm just going to plug in base and height into the formula. So 1/2 times 18, turn off my text to shape. 1/2 times 18 times 12. 1/2 times 18 times 12. So the area is 108 millimeters squared. Remember that our areas always has square units. Okay, so let's do another triangle down here. On this one, I'm only worrying about the shaded area. So the only thing that matters on this one is going to be this is my base and then this as the height. So let's do the formula. Area equals 1/2 base times height. And we got base equals and height equals. In this case, it's 17 and 17. So area equals 1/2 times 17 times 17. And 1/2 17 times 17 comes out to 144.5. All right. Now let's take some parallelograms. It doesn't matter whether you're talking about a rectangle, a square, or a true parallelogram. The process is exactly the same. Your area is going to be base times height. My base and my height on this one for number 6. Base is going to be 18.5. Height is going to be 9. So I plug in just 9 times 18.5. 9 times 18.5. area is 166.5. Okay, for a square, we would just write it in, and the base and height would both be 3.4. Now, in this particular case, on number 4, we don't have the height. We can use 26 as the base, but this would be my height. However, we are given this angle measure. So we can use our good old friend from a couple of units ago, trigonometry, and I know I'm not in front of you, but I know I heard some of you just sigh just now because you hate trigonometry, but we got to use trigonometry to find h. So I'm going to go ahead and write SOHCAHTOA. From the 45-degree angle, this is my hypotenuse, and then over here, this is my opposite. So I guess my h's are kind of mixed up there, but here's my opposite side of hypotenuse, meaning I'm going to be using sine. So sine of 45 degrees is equal to opposite over hypotenuse, which is x, go ahead and put my x here, over 22. Now I put that over 1, cross multiply, gives me x equals 22 sine 45. Run the calculator, I'm going to check my mode first. I'm glad I did, because it needs to be in degree mode. So 22 sine 45, I should type that right, 22 sine 45, gives me x equals 15.56. Now, to find my height, to find my area, I can't write today. Base is 26, height is 15.56, so my area is 26 times 15.56. 26 times 15.56 is 404.56. Okay, so the most difficult part of an assignment like this is honestly going to be the trigonometry portions of it. Let's go into another one, number 2, just to test it out. Actually, let me see. Let's take it back. Let's do number 7. Okay, I got my right triangle here. This line is going to be the height because it is perpendicular to a base. The base here, base, height, and area. Base is 20. Height, we've still got to figure out. I'm going to put my x there. So from this 60-degree angle, this is my hypotenuse because it's across from the right angle. And then x over here is the opposite side. So again, we have opposite and hypotenuse. Use it sine because we got sine is opposite over hypotenuse. Sine of 60 is equal to x over 30. So over 1, x equals 30 sine 60. 30 sine 60 is 25.98. So now we're just going to do 20 times 25.9. Actually make that an 8. Which is 519.6 centimeters squared. Oh, something I forgot to do on these was put my units on all of them. On this one, that was 144.5 inches squared. And over here, this one was also inches squared. So, that's all we're doing for triangles and parallelograms for now. Let's go ahead and move on down to trapezoids and kites. Trapezoids you may have honestly seen before. The area formula for a trapezoid is 1/2 times B1 plus B2 times the height. Essentially, since a trapezoid has two heights, two bases, we got the first base and the second base, we're taking the average of those two bases and then multiplying by the height. Area formula for a rhombus or kite is 1/2 times the first diagonal times the second diagonal. 1/2 D1 times D2. So let's go ahead and jump into these. It doesn't matter which one you pick as which, as B1 or B2. And on your assignment, you're also going to see it set up this way. B1 equals, B2 equals, H equals, and then area equals. I'm just going to be filling these in as we go. So here, base 1 is 6, base 2 is 15, the height is 10, and the area is just 1/2 times 6 plus 15 times 10. 0.5 times 6 plus 15 times 10. So here my area is 105 meters squared. There we go. Now you also notice that on our trapezoids here, we don't have any of the crazy cases with trig like we did before. Really pretty straightforward to do. Now, rhombuses and kites are going to be very, very similar. We're looking for the length of the entire diagonal. So here, well, if we set up this way on your homework, D1, D2, and area. My first diagonal is 12. My second one is 14. So the area is 1/2 times 12 times 14. So 0.5 times 12 times 14 means my area is 84 millimeters squared. Okay, when you're doing a rhombus, we're going to do the exact same idea. Since this is 8, that's also 8, making my first diagonal equal to 16. My second diagonal equal to 10. We got 5 here and 5 there. So the area equals 1/2 times 16 times 10, which is going to come out to 160 feet squared. You're wondering how I did that in my head? Actually, I was wrong. That's 80 feet squared. 1/2 times 16 is 80 times 10. I'm sorry, 1/2 times 16 is 8 times 10 is 80. That's where that comes from. So that's all we have on that. Overall, pretty short and simple. Trigonometry is the hardest part. Those 2 pages are due on next class period. Well, so for first period, it will be due on Monday, and then second period, we'll just make it all of them due Monday. So good luck on it, and I will be available for tutorials if you need help. I'll be back at noon today, honestly, so you can come by after lunch if you need help on stuff as well.